Welcome from Emerald Hill Skies. My name is Doug Lucas, and we're here on the outskirts of Louisville, Kentucky on a chilly night. It is around, 36 or so degrees, and the temperature seems to be dropping. I can tell you it's very icy and cold out there. I cannot imagine that I would have gone out and spent 45 minutes setting up all my gear and sat out there by the scope looking through an eyepiece tonight. But the way this is set up, out there in the observatory, we've got a RASA 11 on top of an iOptron CEM70G mount, and that in turn is on top of a movable pier made by Pier-Tech Adjustable-Height pier. And that pier is located on a nice deep concrete floor down at the frost line inside a Tele-Station 2 observatory, a roll-off roof observatory. And that RASA 11 has on the end of it an ASI, a ZWO ASI2600MC Pro color astro camera, and it is there mounted to an Octopi camera interface, so that we can adjust the tilt out of that. There on that glass corrector plate. The data, they come down along with data from this ASI178 monochrome camera, and they come down to the base of the scope in a little outrigger setup that we've got set up. It's kind of like a rig rack, and it hooks into the data and puts it into a box that converts it into fiber optic cable signal over an iOptron extension, fiber optic relay. And that brings it here inside of my office, inside of a building about 200 feet away from that observatory, where I can operate in a pretty warm environment. So it's pretty fun to be able to do that and not have to worry about the cold. And using that approach, I gotta say, I really don't mind being here tonight. And the other thing that is the payoff is that we get to bring you guys along with us, and we get to look at all this together simultaneously. The object that we've got set up through this RASA 11, and that, by the way, is a live view using it's kind of a security camera made specifically for night vision. TAPO security camera, and there are no lights out there. There's a little bit of moonlight tonight. It's about 80% moonlight as the moon's still rising. But that scope that you see there is looking up at the sky, and we're kind of tilted sideways there with the way the equatorial mount is looking. But you can see the moon starting to come up on the horizon. But I want to tell you that we're looking right now kind of almost due south, and this would be the meridian due south, and right here's where we're looking. So we're only about, 12 degrees probably above our horizon, and we've got this photorealistic horizon set up so that, look, there's my truck parked there. And by the way, that's exactly where my truck is parked tonight. And by the way, I'm over here in this building, here in this corner office. Now, this is a photorealistic horizon and stellarium, so it's not a live picture of the horizon, but it's actually realistic as to what could be seen tonight. I'm about 200 feet away, here in the corner of this building. My truck is parked here. The trees are here on the horizon somewhere, and this red line represents roughly the top of the trees. So I've dropped the picture down a little bit so we can kind of see things rise up above the trees. So only like 12 or 14 degrees above, you can see that we're looking at the String of Pearls galaxy. This is actually a Caldwell object, Caldwell 72. And every once in a while we go back and pick these up. Let's go over to the live view of this right here. Now you're looking at the live view through the RASA 11 being transmitted to you directly as I'm looking at it. So we're seeing this all real time. And let's zoom in about as much as our field of view allows and try to tune this histogram up so we can see as much of this in the moonlight as we can. And what I'm doing down at the bottom there is sort of redefining what we're going to declare as black. It's kind of like we're saying, what's the new black in our picture? Because we're not black, we've got light pollution and we've got moonlight. So what's going to be the new black? And that's what the histogram at the bottom does. And then this line, the mid-levels, that kind of represents how much we're going to accentuate all of the light in between. And in the Caldwell Objects book by Stephen James O'Meara, O'Meara writes about Caldwell 72, and he actually writes quite a bit about these two objects, NGC 70, which we've already observed, and NGC 72. He writes quite a bit about them. It's Caldwell 72, also known as NGC 55. And he says it's visible actually in binoculars. Can't quite see in the naked eye. And he says that most people list it as a magnitude 7.9, but using his binoculars, he actually guesses that it's closer to 7.5. And he sketched it here in the book. Let me show you where he sketched it. Kind of a nice looking sketch. And he says the longer you look at it, the more you see the nuclear region starts to appear more irregular. Faint stars begin to appear along its length, and we're starting to get those. Let me get my mouse cursor out of the way. This is with 11 minutes of integration, 11 minutes of combined 20-second exposures at a gain of 100 and a shutter speed of 20 seconds. And he says it kind of, he imagines that it's a comet in his view, like an extragalactic string of pearls. He says that in his opinion, it sort of begins to pulsate with dim, glittering lights. I don't know if we're seeing that pulsating. He says it looks most dramatic when he looks at the nucleus. Ribbons of dark material lace its entire nuclear region. It's like a comet that's been snared in a black net. Lots of faint fuzzies, as if tiny explosions have blown apart the hull of this extragalactic traveler. He says it's kind of like clouds. He pretends like the knots are like streams covered with black ice flowing through banks of snow. And he says it's one of the most spectacular galaxies available to amateurs. But it sits low, and sure enough, it's low to our skies tonight. Like I say, it's about 10 degrees-ish. Yeah, 10.2 degrees tonight above the southern horizon for us. It's an extragalactic wonder and enjoy the beauty of our hobby, he says. So this is the only new object. We have a few stragglers of the Caldwell list that we'll pick up along the way. This is the only one that's visible to us tonight. Let me turn to you guys on the stream here and say hello to Stu. Good to have you back, Stu. And Tiffany couldn't make it. She had to do something with family stuff. She stopped by to say hi to us before she left. Ray is there. Vic, good to have you here. Vic, I don't know if we know where you're observing from. Stu is in Tauranga, New Zealand, and Ray is in Phoenix. Dane, good to have you on board. I think you're in Minnesota, if I remember right. Joey, good to have you on board. You're just into thaw. See how it's supposed to be done. Joey, I forget where you're broadcasting from there. Stu says Caldwell 72, also known as NGC 55. It's a galaxy located 6.5 million light years. So I'm going to put that in our observations here in our log. 6.5 million light years. I'm using Deep Sky Planner 8 to do the logging here. In Sculptor, discovered by James Dunlop in 1826 when he resided in Australia. Dane says if they call them binoculars, why don't they call telescopes unoculars? That's a good question, Dane. Along with its neighbor, NGC 300 is one of the closest galaxies to the local group, probably lying between the Milky Way and the Sculptor group. Stu says, well, because the English language is stupid and Latin is even worse. Vic's observing from North Texas. Okay, good to have you aboard, Nick. I'm sorry to hear it's cold even in North Texas. Beautiful, beautiful string of pearls, we're going to say. I've already set up our session tonight. I think it's session 128. So as you can see, might be able to just catch the edge. That's all we've got from the Caldwell list that we'll be able to observe tonight. So let's close that list out and let's open up the hidden treasures list. And just make sure there are no stragglers in that one that we can catch. We're going to say show us only the ones that we've not observed that we can see in our local horizon. As we look at it now, click run. No hidden treasures available to us tonight. We have a few more stragglers in the hidden treasure list. Not too many left in the hidden treasure list. Let's just check. If we say Alt as ignore the horizon and tell us how many are left to observe, we only have 10 objects left in the hidden treasures list. So let's close that and let's open the secret deep list. These are all different observing lists that were established by one person or another. This one's another one by Stephen James O'Meara. In the secret deep list, I'm going to say, show us the ones we haven't observed and only that are above the local horizon at this time. Oh, we've got one of those at 18 degrees. So we'll go there next. All right, so this is a nice looking object, isn't it? As Ray, thanks. Ray is saying to you guys, don't forget to like the video. That raises it. If you do like this kind of content, like the video, please. That raises it in an algorithm and gets it up in everybody's like heads-up display, so to speak, a little bit faster. This is a nice thing you can do, and it doesn't cost you any money. Thanks, Ray. Stu says, funny how Texas is so huge. Texans don't say they're from Texas. It's always like North Texas, Central Texas, West Texas. Boy, you're right. I think it takes us here, Stu, to put it even more in perspective. Leaving Louisville and driving to the top of Texas takes around, trying to remember, is it 24 hours drive? I think. And then once you get to the top of Texas and you want to drive to the bottom of Texas, that's another 24 hours, if I remember right. Pretty much. Stu says only 10 more than we win. That's right. Exactly, Stu. All right, so we're going to snap a picture of this. Save it exactly as seen. C72. It's a beautiful object and quite large. So don't get too spoiled because these get successively smaller. All right, so we've saved that. Now we're going to go up and use our little programming sequence. These are automated little programming snippets that we've made. We're going to say next target. And the next target we want to go to is NGC 134. It is Secret Deep 2. So we're going to say slew to it, NGC 134, NGC 134. Didn't have to move very far, did it? There's the live view of the sky. You can see the moon is becoming more and more a factor. Let's have a look at our planetarium software. So where we're aimed is not too far from the southern azimuth compass point. And this is about 18 degrees above the horizon. And apparently what this is the giant squid galaxy. So let's go to our name here. This one's called Secret Deep. What is the abbreviation for Secret Deep? See, Secret Deep 2, that's NGC 134, a galaxy in, wow, what are we in, Stu? Maybe, is this in Sculptor also? We're going to guess Sculptor, and then tell us if we're wrong, Stu. Let's go back to our screen view, and there you see kind of an edge-on spiral, the giant squid, I guess it's called. Now let's come back to our this is a live view through the 2600. While that's coming up, I've got to go over and get the Secret Deep book, because I don't even have that out. We haven't observed from the Secret Deep lately, so I don't even have it out here where we're looking. Secret Deep number 2. How about that? Object number 2. The giant squid, NGC 134. Stu says it's a barred spiral. It resembles the Milky Way. It's 60 million light years away and part of the Sculptor constellation. So we were on track. It's an edge-on galaxy and Sculptor, about 10 degrees south-southwest of Caldwell 65, the more popular silver coin galaxy. Let's reset our display histogram, and let's take the large histogram and reset it. I think that color balance looks pretty good. Let's move the mids up now and let's zoom in some. To get rid of some of that grain, let's move our black level just barely to the right. I'm holding down the shift key so we don't go too far, and that lets us fine tune it. Need some more integration, some more time, more exposures. We're only at 2 minutes. Need some more exposures to get rid of the rest of that confetti looking grain. But already you can start to see the core. Now we're zooming in. This is 206 degrees of our optical zoom. So we're into the digital zoom. Look, there's another little galaxy up here that you can see. And there's something, I don't know if that's just a bright star. Let's see what O'Meara says about it. It's a treasure that's relatively easy to acquire. It's faint, so it's a challenge, especially for mid-northern latitudes. But it's a stunning object when seen from the southern skies. It's often attributed to John Herschel, but Herschel did note that it might be the same as James Dunlop, and that's what you're saying. Oh no, that was the last object, wasn't it? A faint round nebula is what Dunlop wrote. Herschel sketched it, showed its spindle shape, tapering edges. He classified it as an elliptical nebula normal, but we know now it's a spiral. It's wafer thin through small telescopes, but in larger photograph, astrophotography, it's an edge-on spiral with an oval hub surrounded by a large symmetrical disk of dust and starlight. 14 degrees from edge-on. Plumes streaming off the galaxy's major axis in both directions. I don't know if we can see those plumes yet or not. Like flagella of some extraterrestrial euglena. What in the world is that? It's warped, resembling a bent final LP left out too long in the burning sun. Might have been stretched by another galaxy. He says there's a whole group here. Tells you how to find it. A 13th magnitude star can be seen northwest of the nucleus. Could easily be mistaken as a supernova. I guess that must be this. Maybe that's this star right here. $60 million, is that what you said, Stu? Yeah, it's not a true member of the sculptor group, is it? Stuart Parker, who lives in Oxford in New Zealand's South Island, did discover a supernova here. So that'd be one of your neighbors, right, Stu? Oxford in New Zealand's South Island. He had taken a astrophoto through a Celestron 14 telescope. Core is mottled. Arms look like moist breath on a string. Where does he get these descriptions? Southern arm is also knotted in a most delicate manner. NGC 134. Okay, so we're going to do our little observation here. You can definitely see the core. We could definitely see the brighter core and even make out some dust trails in the arms. 14 degrees from edge on, and according to both Stu and O'Meara, glad you agree with O'Meara, Stu, lies 60 million light years away. Reminded us of the Milky Way. Other end of the country, but remarkably similar name to Stu's location. Cool. South Island. Barred spiral. Yeah, you can see the bar here. Let's zoom in. Boy, it just starts pixelating before we can make much out. Very faint, but this is only 8 minutes of time exposures. It's neat, you can see that other galaxy right here. Let's see if that's NGC 131. So this is NGC 131 right here. It's interesting, isn't it? Whenever we can make an observation like that before we go look at it in the planetarium software, I kind of like that idea because it sort of makes us feel like we're still able to do, science, doesn't it? That we could still discover things. If that galaxy had not been discovered, we would be able to discover it tonight. So that's fun. All right, I think that's all we can do from the secret deep. So let's save that. Let's see, we've looked at the secret deep, hidden treasures, and Caldwell. Let's look at one other list tonight just to make sure, and that is the Herschel 400. And I think we don't have too many left in the Herschel 400 either. Seems like, let's just look first. If we say observed, no, and time is now, that are available above our local horizon model, and then click run. Well, we have 3 of the Herschel 400, so let's go catch them real quick. First, let's grab a picture before this object is lost. We'll go up to our sequencer and say, next target. Stu reminds us the light we're seeing from this galaxy was generated when the dinosaurs were going extinct. Wow, Stu, that does put things in perspective, doesn't it? That's crazy. All right, so the next thing let's go to here is NGC 1052. NGC 1052. And we'll say slew to that. This is Herschel 63-1. We don't often use Herschel's numbers because they're so complicated. Why did he have to use something so complex? But I'm going to put here NGC 1052, a Herschel 400 object, a galaxy, and is that Cetus? Is that right? C-E-T-U-S? Yeah. Elliptical, discovered January 10, 1785 by William Herschel. And elliptical. All right, so let's have a look here. It'll take a second. So let's show chart here. You guys that have been on the channel before, you know the way we do this. We plate solve pretty much every target just so that we make sure it's in the center. And all that's run by our sequencing in SharpCap. That's the imaging program we're using here. And while that happens, we can go over in our, is this it? Show chart. Wow, look at that. 1052. Let's turn on our field of view indicator. We're actually going to be able to see two galaxies side by side here. I take it maybe we've already looked at 1042, or maybe 1042 is not on the Herschel list, one or the other. And then 1035 is up here. Let's back away and just get our context of what part of the sky we're looking at. This is over the top of our building, so from where the observatory is over there, if you could just imagine the observatory is over there, the telescope's looking toward the southeast, so it's kind of looking out that direction. And if we look at it on our horizon here, our photorealistic horizon, you can see the building is right here. This is the top wall of the observatory. So we're looking almost due southeast. And yeah, we're going to get to see NGC 1052, which is an elliptical, and it's going to be side by side with NGC 1042, which is a face-on spiral. We'll also maybe see these two, NGC 1048, and whatever that is, and then NGC 1047. So pretty nice view. Several galaxies there, right? Okay, so let's go over to our live view now. And the first thing I usually have to do is reset this display histogram. Ray told us this probably a year and a half ago to start that way. Now if you look, we are a little bit off, and on our, so let's do a reset down here of our large histogram. And that took care of a lot of our, I don't even think we have to do a color match, but let's do a color balance just in case. Let's move our black level up to right there, and then let's move the mids up. Wow, this is a very tiny object compared to the ones that we've been looking at. Look how much smaller it is. Okay, so this is our object of interest, NGC 1052, the elliptical right there in the middle. But over here is the beginnings of this 1042. And I think 1042 is fainter, but a little bit more interesting. And then these two, 1048, are right here. You can already make them out, can't you? Wonder if we zoom in on this, if SharpCap ever shows us what this is. doesn't. We have no idea what that is. It's an unidentified galaxy. Well, anyway, this one here on the left is 1048. That's 1042. And then our object of interest is 1052. Let's go back to the live view now. So here's 1052, and that's that face-on spiral, and here's the 1048. So 1048, 1042, 1052, and then 1047 is out here. Now that's 100% zoom. Let's go into some more of our digital zoom. That's at 156%. Look at that large core in this elliptical. 63 million light years, has a liner-type active galactic nucleus which signals intense starburst activity in the galaxy's center. Dane Christian, why did he have to use something so complex, as Doug is sitting in a state-of-the-art telescope station? No, but I mean his numbering system, Dane. Why does he have to number things by like 6 different Roman numerals and then follow them up with other numbers? But yeah, Dane, you're a rascal. Making fun. But it does seem complicated. H63-1. Why is it called that? Anyway, this is 1052, so that's very kind of you to say encouraging things about our observatory here, Dane. So very nice of you. 1052. Let's go ahead and bring up the log on this and say, Stu told us this was 63 million light years distant with a liner type active galactic nucleus. That just sounds so interesting, doesn't it? Which signals intense starbursts. Sounds so exciting. Just makes me want to go get a radio telescope. Activity in the galaxy center. Fascinating. We could also see several neighboring galaxies in this field of view. Very cool. Let's go see if we can find NGC 613 now. NGC 613. LINER stands for Low Ionization Nuclear Emission Line Region. Low Ionization Nuclear Emission Line Region. And emission line is hyphenated. Low Ionization Nuclear Emission Line Region. Let's all memorize that. This is NGC 613. It's a galaxy in SCL. What does that mean? SCL. Santa Clara? I think not. Let's show chart and look up what we're seeing here. This is in, I guess, Sculptor again. This is like Sculptor night. And you can see what we're looking at here. NG666. This is almost amazing, isn't it? Look at those arms that look out like kind of like, oops, sorry, kind of like tadpole tails or whirligig. I think tadpole tails. Whirligig galaxy. Boy, it's a beautiful galaxy, isn't it? NGC 613. What can you tell us about this, Stu? It's a barred spiral located 67 million light years away in the southern constellation Sculptor, discovered 1798 by the German-English astronomer William Herschel, thus on the Herschel list. Ray says, also in Sculptor. Dane says, just kidding, Doug. I love you. One of my favorite moments of 2023 was helping you fix a cable. You're right. Yeah, you did that, Dane, for sure. Ray, it looks more like a propeller. You're right. I think you're right. A propeller would be a better description. It's very cool, isn't it? All right, let's go over to the live view and see what we can pull out here. Let's do a reset in the display histogram that Ray taught us to do. And then we'll reset down here in the large histogram and do a new color balance and pull back the mids and zoom in. So that's about, for context, that's about 100% there. So let's go ahead in a little bit deeper, 187% into our digital zoom. So we're at 187% of our optical setups potential. Even though we're only 100 seconds into this, I think you can already see that propeller nature of this object. Barred spiral, 67 million light years away. Herschel. Ray termed it a propeller. He's right. After just 2.5 minutes of integration, we could already make out the arms, which looked like the propeller blades or swirling tadpole tails. Bright core, slightly oblong. Super interesting. Three minutes. You know, guys, how is this possible in just 3 minutes to be able to pull in these objects that are so dim? Let's do the last remaining object we can catch in the Herschel list. You might wonder, why are we doing these stragglers? It's because when we did the Herschel list the first time, we weren't very careful with our altitudes, and before long, there were some objects that just weren't visible anymore. So we just have to catch these things as the year passes. And The next object is NGC 720. NGC 720. You know, the whole, if you're new to the channel, or if you've just tuned in and you're watching the recording, when I started in astronomy as a kid, I mean, I probably started getting interested in the stars maybe in 7th grade. I had no idea there were this many objects that were kind of, as it looks to us, it's like they're fastened to the night sky. And if you can imagine the night sky as a celestial sphere, like the inside of a big black dome, it's like these little objects are tacked. They're just plastitacked or superglued onto the inside of this imaginary black dome that we'll call the celestial sphere. I don't think I really understood that there were this many objects up there. I could see the stars, and so I understood those. And I kind of understood the way that, to quote that famous soap opera that my mom used to watch, as the world turns, it gives us the appearance of the celestial sky sort of spinning overhead, rising in the east and passing to the west. I just never understood that along with all those stars, there would be these interesting objects. And even, this is going to be bad, you're going to probably think badly of me. You're going to say, how could I not have known that? But even when I started this era of astronomy, and by this era I mean in the last year and a half, 2 years, 2.5 years, whatever it's been, even in the last 2.5 years of my life doing this version, in other words, electronically assisted astronomy, it never dawned on me that these objects are static with the stars. So they're like, the objects that we're looking at, for the most part, move in apparent motion so slowly that it's as if they're fixed all up there in the night sky. So they have specific addresses that you can go to on the celestial sphere, like we have a zip code or a street address. These objects have specific addresses, and you can always go to that address. And the address we use are these hours of, you know, charting across the night sky in terms of the hours and the declination. This becomes its address, hours of ascension and the declination, that is the degrees. I just didn't understand that. And I'm amazed that there are not just dozens, not just hundreds, but thousands of different objects that we can observe. And this being one of them, NGC 720. So we'll zoom in on this. That's about 170 degrees. This looks like an elliptical. Yeah, Stu is telling us. Let me open up the little log. We do these logs in part because once we do a log on the object, it's sort of a permanent record that we've observed it at least once. So an elliptical in Cetus at 80 million light years, Stu says, 110,000 light years across. Herschel discovered it, obviously, on the Herschel list. And Ray is chiming in, saying, yes, the address is always the same to us because everything is so far away, he's guessing. That's right. It's moving relatively fast where it lives, but because these distances are so mongo huge, the apparent motion to us is just still. I mean, it takes literally years and years and years to begin detecting them with even the most precise equipment. And our time frame is so small, Stu says, right. Even in our time frame that we've lived as humankind, it's so small. You're right, Stu. So this elliptical doesn't appear to have a lot of detail, does it? It's just kind of a blob that's oblong. We'll zoom in to 200 degrees. I'm sorry, 200%. But this is just 4 minutes. I suppose if we looked at it for a little bit longer in an astrophoto style, we'd see more detail, but it's really just a blob to us after 4 minutes. Okay, so that catches us up with what we can see with the Herschel list. And I'm just going to, for a moment, say ignore the horizon and tell us how many objects we've not observed. Oh my goodness, is that the last of it? That's the last of the Herschel list. And you saw it live. And I didn't even know that it was the end. But here we've just finished the Herschel 400 together. So many of you who are live with us, or else you're watching recorded, you've walked with us through all 402 objects on this Herschel 400 list. I don't know why it's 402. You've walked with us through all these, and we've just finished the entire list. Now, for those who do this kind of thing to get thrills from the International Astronomical Union, we send in all these observations and they send us a badge or something. But I don't mess with that. But we've now completed the Messier list, and you saw we're getting closer on the Caldwell list. We're getting closer on the Secret Deep and the Hidden Treasures. But tonight is a really big deal because we finished the Herschel list together. Scott Gridley is on with us, and Scott says, woohoo, congratulations. Scott says, thanks for the stream. I've been watching silently in the background, watching the World Series game, but appreciating the dialogue and images. Stu says, an oblong blob. And Stu says that's all that Chandra and Pan-STARRS see too. So thanks for checking that out, Stu. Stu's saying, quoting Edmund Hillary, we knocked the list off. And unfortunately, I think the YouTube algorithms are blocking the colorful word that Hillary used for a list. But yes, we knocked it off by God's grace. And Vic says, congratulations, young man. You're nice to say that, Vic. Well, congratulations to all of us because we've done this together. There is a sharpless list, Ray. I don't have that yet, but I'm sure we'll try to go to that next when we get through all of these. So thanks for asking. By the way, I should have asked before, are you guys hearing the music at all? I for some reason, I can't get this music exactly right. And is my voice right? So you might come back and say that, because I have trouble, since I'm not out there in the live stream hearing myself exactly, I have trouble getting an idea of what this should sound like. Okay, so I think we're going to take a picture of this just because it is monumental. It's the last object that we saw, NGC 720. So let's ignore. Stu says the music's very faint but good. Okay, that's the way we want it. We don't want it to be very loud. And the voice is good, but he's not hearing any music. Okay, thanks. I'm going to put these in order of the object number and go back to 720 if we can real quick. And I'm going to edit that observation because with this object, NGC 720, we officially finish observing all 400 objects on the Herschel list. Yay. All right. And that's about all the fanfare we do with that, of course. But that's exciting, isn't it? That's kind of fun. So I'm going to save this Herschel list. Well, I'm glad we checked. What if we hadn't checked? Now let's go to the list that we were going to start on originally, which was the Cosmic Challenge list. And in the Cosmic Challenge list, now back to reality, because we have a lot of these. Let's just ignore the horizon for a minute and ignore the timing. And let's just check how we're doing. There are 325 objects on the Cosmic Challenge list, and we have yet to observe 154 of them. So we are just over halfway done. Okay, so now we're going to set it back on. Show us only the objects that are above the horizon that are visible now. We're going to run that equation, and there are about 104 tonight that are visible. So plenty. What is that noise that we keep hearing? I wonder if that's got something to do with our scope. No. Anyway, let's put these in order of altitude if they're not already. I think they are. No, they weren't. And let's go to well, maybe we should do best. Put them in order of best. Now look at that. It says we should go look at Vesta, which is an asteroid. That's interesting, isn't it? All right, let's go look at Vesta. So enter the name. We're going to say here Vesta. Sounds like somebody from a James Bond movie. Slew to go find Vesta. What happened to our scope? Our scope has disappeared. That's sad. You can see the sky cam, and it's showing you that we're scanning through the sky, but our scope has disappeared. See if I can get that back. I know where that's coming from. That's coming from our phone that we've got. Okay, so to fix this scope cam, it looks like we dropped our... The way we do our scope cam, this is kind of complicated. The security cam works off of an app, sadly. It's not a true webcam. So it's an app, so I run that security app on my phone. Well, since Windows has no way to view a phone, I try to run this little thing called Reflector 4. And once that's up, then I try to mirror the phone through Reflector 4 to a window on my Windows PC. And It's going to give me a number there, and I have to put that number in. And now we're mirroring my phone. So you can see there, it's just a big picture of my phone. Now we've got to go find, once again, the security camera. So I don't know why that dropped, but for some reason that app dropped. Now, we just want that to sort of fade back into the background. And now you see our scope cam. We have to go down here and say, choose that. And there's our scope cam back. So for whatever reason, that little app connection and mirroring the screen does drop sometimes. Anyway, Vesta. Why does it sound like a James Bond movie? Vesta is one of the largest objects in the asteroid belt with a diameter of 525 kilometers. That's huge. 326 miles. It was discovered by the German astronomer Heinrich Wilhelm Matthias Olbers Vesta. No, I'm just kidding. His last name isn't Vespa. On March 29, 1807. Vesta is thought to be the second largest asteroid by both mass and volume after the dwarf planet Ceres. Vesta is the brightest asteroid visible from Earth. It is regularly as bright as magnitude 5.1, at which times it is faintly visible to the naked eye. So that's pretty cool. Now, what we're doing now is we're doing our plate solving routine. And if you're new to the channel, maybe you're just tuning in, by the way, welcome. If you're watching the recording, plate solving is a feature by which SharpCap uses plate solving technology to capture a photo of the night sky through the telescope that you're viewing, through which you're viewing. And then it passes that off to this plate solving sub-program that SharpCap interfaces with. And this plate solving Ninja application compares that picture that you've just snapped of the night sky with its file photos, and it aligns your telescope real time to where you meant to go in case there are minor differences. Once you have slewed across the sky, slew just means move. Once you've moved to a different part of the sky, maybe your mount got out of sync by 1/10 of a degree or something. Well, plate solving realigns it. What that means is that we can literally use a crosshair. And we can kind of choose our crosshair. We'll choose a very simple crosshair here. And we can kind of zoom in, and supposedly Vesta should be here in the middle of this picture somewhere, right where the crosshairs are. So what do you think? If you were Vesta, where would you be? Now, to solve this puzzle, let's go to our planetarium software. And we get there by saying show chart from our our targeting software, Deep Sky Planner, which also is our observing logging. And you would have thought that we could have observed where Vesta is using Stellarium, wouldn't you? So let's do a search and see if Stellarium has Vesta. And sure enough, it has something called Vesta, but it's kind of odd that there are so many, isn't it? That went to a different place. So that's a star named Vesta. It's odd, isn't it? We're looking for an asteroid named Vesta. And that does look like that in Stellarium it thinks it's the planet. So that makes me wonder if maybe the location that we have in the observing software is a little bit off. I think we would want to trust, wouldn't we want to trust Stellarium more than we would the targeting software? So we have a conflict. Our targeting software thought Vesta was in one place, and Stellarium thinks Vesta is in a different place. So just for fun, let's tell the telescope to go to the place where Stellarium thinks Vesta is. And we do that by using Stellarium's telescope guidance system. And you can use them alternatively while they're both hooked up. Now we've got the object chosen, so we're saying current object, and then we're saying slew, but look how low it is on the horizon. There's at least a chance that it's so low that there'll be a tree in the way. Now, why do I say that? I say that because look at our photorealistic horizon here. See that tree that's right there off the eastern edge? Ooh, there's another problem. Look at the moon. The moon's right there. That's not fun. So there's that tree. Now this red line is what I think is closer to the real horizon. And I have the photo lowered below what I think is the real horizon. But just looking at the telescope in the scope cam view, it looks like we're up above the horizon, doesn't it? Maybe? All right, so now let's go back to the real-time image. Oh yeah. Now let's do a plate solve again. Oh, we're live stacking, sorry. So we're going to have to stop live stacking. Go back to 3-second exposures to get the most out of our, we'll bump our, now we'll, yeah, there's that tree. Can you see the tree sort of mixed into our view? It's like, it's just some of the leaves are mixed into it. You can kind of tell because it sort of looks misty, doesn't it? With this plate solving, though, the telescope and the mount are aligning immediately, like directly with the sky. And there it should be aligned. Now that might be Vesta right there in the middle. Let's do our crosshair. Oops, we're still aligning, sorry. False alarm. Okay, so now I think it's settled. Now let's do our crosshairs again. Rats, still nothing stands out to us. So in this view of Vesta, oh, I'm sorry guys, I had you on the slew cam. Thanks, Stu. In this view of the night sky through the tree and some moonlight, the moon is so close. Let's go to our sky view. Yeah, so you can see why this is flooded with moonlight, because that is the moon that you can see there. But we're still making out stars. Now let's kind of begin to look at this shape. Like look at this question mark deal. And here's a line of 4 stars. Now let's go back to our now here's this, maybe this is the line of 4 stars. So if this is indeed, yeah, it says Vesta asteroid. If it is the asteroid, then you would think there would be 4 stars here. This one's out of line. And Vesta is in a little equilateral triangle view with the dimmest of the 1, 2, 3, 4, 5. So if that's this, and it might possibly be you guys can help on this. Slew cam again. Sorry, thanks. So there's our live view. Notice we have a bright star up here with a twin. Anybody see any shapes there that you want to take back? Let's go look at Stellarium now. And oh, here's our field of view indicator. So look, that might be that star with the twin. If so, you could almost sight along from the dim star to the bright star. So let's go back here. So there's the dim star to the bright star. So really, Vesta is supposed to be right here somewhere. Dim star, bright star. Now let's find this arc, like a bow and arrow. There's the string, and there's the bow. Dim star, bright star, arc of stars, bow and arrow. Let's look for that. Dim star, bright star. What is that line? Oh, that's our photorealistic horizon. So we're coming up above the trees is what it's basically saying now. We're rising above the trees. Dim star, bright star. Is this the arc? It is. There's the arc with the string. So let's sight through the dim star, bright star, through the bow and arrow, I got to go down here now and say align with reality again. Dim star, bright star. Here's the arc. Now we want to find two objects together. Dim star, bright star, arc, two objects together. Or is it this? Now look, that's a unique looking object, isn't it? Look how that almost looks disc-like. I believe that would be likely to be Vesta. Dim star, bright star, through the arc, Vesta, neighbor star, two, one, two, one, 2, 1. So it's surrounded by 3 pointers. So if this is Vesta, could that be 2? Boy, there's so many stars. This is a very star-rich area. Anybody seeing it? Challenging. That's why they call it cosmic challenge, right? Well, let's just be patient here. Let's figure this shape stuff out. I don't suppose if we use, no, it's not going to be in our deep sky image annotation because it's not deep sky. It didn't really, I don't feel good about the fact that it's over here since it's supposed to have done a plate solve for us. Let's do one more. There's Vesta, current object, slew. It did make a minor adjustment. Help me out here, guys. Here's our arc. Here are 2 stars. But Vesta should be in the middle of this picture. If all things being equal, why is it not down here? It should be all the way down here, I would think. Okay, let's look in Stellarium again. We could have the wrong stars for these 2, right? In the basic neighborhood where Vesta is, what shapes can we identify? Here are 3 stars in a row that are pretty memorable. They're much closer than that twin. So if we sight dim star, bright star, all the way over to a place where there are 3 stars in a row like Orion's belt, that might help us. Anybody else see something memorable? 3 stars in a row, and they're on a 45-degree angle. Let's go back and look at the live view again. So if we sight along these 2 stars, we should come to 3 stars in a row at a 45-degree angle that look like Orion's belt. I need a drink. I just tend to think it's this. Because it looks disk-like and not fuzzy, and that's what an asteroid would look like. And maybe these are the 3 stars? No? Yes? It could be. Is the one on the left slightly brighter, and is there a little more space, truth be told? Well, it just depends on which 3 we're seeing. Those 3. Okay, let's get a little bit closer here. If it's Vesta, there should be a bowl with a star in the middle, and Vesta would be the cherry on top. So our theory is this should be Vesta. I suppose this could be a bowl, right? That could be a bowl, and there are some stars in the middle, and that could be the cherry on top. We're going to call it this. And there are 2 stars there, and there are 2 stars there, and there are 2 stars there. So if this is Vesta, there are 2 stars there, and 2 stars there, and 2 stars there. Look at that. 2 stars, 2 stars, kind of pointing at it. Here's a 2, there's a 2. Here a 2, there a 2, everywhere a 2. The moonlight is blocking the view. Maybe, but I think it's this disk right here. You're saying the moonlight might be blocking out some of the stars we're seeing in Stellarium? It's a good theory, Ray. So we think it's right here. Let's go back and look at our full RASA field of view. There's the full RASA field of view. North would be up this way, and here North would be up this way, I think. Look at that. It even identifies craters on Vesta. Well, the most interesting thing that I'm seeing here is that it does have a distinct look when compared to the other stars. It appears disk-like. It is in line with those stars. And we did see this little arc here. There is a 2 and a 2 and a 2 and a 2. So we got these two pointing at it, these two pointing at it with 2 in front. Here's a line of 4 stars pointing at it. These two roughly point at it. Those two point at it. These two point at it. And farther away, those two kind of point in the direction of it. Everything's pointing at what we think is Vesta. So if we go here, these two point toward it. There's the arc. Now take a look. These two point at it. Those two point at it. Those two point at it. These two point at it. I tell you what, gang, I think that's it. We're going to call it. I'm going to go over here and I'm going to say, wow, that was not easy at all. This required so much patience. We had to look for star pointers, but we saw an object that appeared more disk-like. Okay, I tell you what, let's also look in Cosmic Challenge 20 now and see what Harrington says. Glimpsing Vesta. Man, he gives you star charts, but they're worthless because they're done in 2011 through 2018. On January 1st, 1801, the solar system became a little more crowded still. That night, the Sicilian astronomer Giuseppe Piazzi stumbled upon the first asteroid, which he named Ceres, after the Roman goddess of grain. Now reclassified as a dwarf planet by the International Astronomical Union, Ceres was the first object discovered to be orbiting the Sun between Mars and Jupiter. As is so often the case in astronomy, once the first of something is discovered, the floodgates open. That certainly has been the case with asteroids. The second asteroid, Bias, was found in 1802, while the third, Juno, was discovered in 1804. By the end of the 19th century, several hundred were known. Surprisingly, even though Ceres is the largest member of the clan at 600 miles, it is not the brightest. That honor goes to Vesta, the fourth asteroid discovered. Vesta was found on March 29, 1807 by German physician Heinrich Olbers. Although oblong, Vesta only has an average diameter of 320 miles. It can outshine Ceres by more than a full magnitude of times. While Ceres reflects about 10% of the sunlight striking it, Vesta's bright surface reflects more than 30%. Why that is exactly remains a mystery, although studies show that Vesta's surface is apparently covered with basalt, a byproduct of volcanism, which probably has something to do with Spock. This suggests that at some point in the distant past, Vesta was volcanically active. Oh, that's what it means. Or perhaps it was part of a larger body that was. It talks about, it has the distinction of being the only asteroid to crack the naked eye barrier. For 1 to 2 weeks, either side of it reaching opposition. Vesta can be seen without any optical aid, provided the sky is clear and dark, and you know exactly where to look. The rest of the year, it's magnitude. It varies quite a lot with magnitude, between 5 and 6.5. It can be in a crowded part of the sky where many faint stars will give it plenty of competition. Yes, I believe you, Phil Harrington. Well, that's all he can tell us, but we're going to say that we saw it. One of the most challenging objects ever to identify. Yeah, Ray says, you do have to have good eyesight. Stu says, numerous fragments of Vesta were ejected by collisions 1 and 2 billion years ago that left 2 enormous craters occupying much of Vesta's southern hemisphere. Debris from these events has fallen to Earth as howardite, eucrite, diogenite, that's HED meteorites, which have been a rich source of information about Vesta. What? You mean that our scientists claim that we can identify which meteors have hit the Earth and become meteorites that are from Vesta? You gotta be kidding me. That sounds so far-fetched, doesn't it? But I'm gonna say I believe just because our scientists say it so. Well, that's sad. It wouldn't let me record an observation of Vesta. Why is that? Something wrong with the... I'm going to have to report this to Phyllis. Access violation. Let me take a picture of this. Vesta access violation. I bet it's because it's not stored properly. Because remember, it was off. Okay, so we can't even check it that it's observed, sadly. I'll have to talk to her. Okay, the next object is zodiacal light. How do you observe zodiacal light anyway? Have any of you guys ever seen zodiacal light? You know, zodiacal light is that greenish glow that's on the horizon, like a few hours after the sun sets, right? Sorry, let's look it up and see what he says. Seeing the zodiacal light and the Geigenschein. We all know that our solar system consists of the sun, 8 major planets, 3 dwarf planets, and hundreds of satellites, tens of thousands of asteroids, and probably millions of comets and Kuiper belt objects. We are also usually told that in between these bodies are huge gaps of nothingness. In reality, interplanetary space is anything but empty. In fact, it's littered with debris and dust left over from the formation of the solar system itself, as well as scattered rubble from collisions between asteroids. Each grain of this so-called interplanetary dust is like a tiny microplanet orbiting the sun. Interplanetary dust particles typically range between 10 and 100 micrometers across, which is smaller than the width of a human hair, although some may be a meter or more in size. Seeing them from the Earth is out of the question, or is it? While we can't hope to see a single particle, we can enjoy their collective presence in the night sky immediately after sunset or right before dawn. When sunlight strikes these uncountable grains of dust, we can see their combined glow in the sky. Since most of the material lies along the ecliptic, just as the planets do, we call this phenomenon the zodiacal light. It's a very dim, wedge-shaped cone of light rising up above the western horizon 60 to 90 minutes after sunset. Any hint of moonlight, light pollution, clouds, or haze will obscure it completely. Small window of opportunity. He saw it in the Everglades. Have you guys ever seen the zodiacal light? Related to the zodiacal light and the zodiacal band is the Geigenschein. It's also known as the counterglow. It's the brightening in the zodiacal band at the point in the sky exactly 180 degrees away from the sun. And that's because those things are at full phase, just as the moon is when opposite the sun. So you get reflected sunlight from the opposite side. You need perfectly dark skies, perfectly dark adapted eyes, nowhere to look. I don't think we're going to be able to do that from the outskirts of Louisville. Sadly. Anyway, but we've seen Vesta. So I don't know what to do about this zodiacal light thing. We're going to have to leave it unobserved for now, aren't we? Bummer. All right, let's go on to the next object. NGC 247. NGC 247. It's a galaxy. And it's number 36 on his list. You also can get 253. That's not on his list. Okay, so NGC 253, the silver coin galaxy discovered by Herschel. It's one of the finest edge-on spirals. Easy to find. If it's too easy to find, try your luck with 247. It appears nearly as large as its neighbor, but is about 2 magnitudes fainter. Look for it, and it tells where to look for it. Okay, let's try it. 247, side by side with 253. Okay, so this is NGC 247. And let's change to 20 seconds manually and 100 gain. And do a plate solve. NGC 247, which is Caldwell 62, or the Claw Galaxy, is an intermediate spiral galaxy, although it's sometimes classified as a dwarf spiral, about 11 million light years away in the constellation Cetus. It's a member of the Sculptor group and is 70,000 light years in diameter. I bet we observed this already in the Caldwell objects. If so, why isn't it marked off, I wonder? Right? Maybe we haven't observed it yet. Or maybe it's because in the Caldwell objects we have it listed as a Caldwell object. Phyllis told me this would happen sometimes, that depending on how things were added to the observing plan, there could be duplications like this. Okay, so we're plate solving for this. And it looks like there has been a correction. Let's show chart on this too. So this is 247, the Needle's Eye Galaxy. Boy, it looks big, doesn't it? So where is 253? Oh, it's over here. Yeah, so it's outside our field of view. Okay, let's go to the live view now. Reset the display histogram. Live stack this. Clear the live stack, because we're doing that manually. Stu says we have seen this before. Well, that's a shame. How did you remember that, Stu? Oh, there it is, the middle. Uniocular. Like binocular. Stu says, well, we might not be able to see this with a fat moon or a telescope. Worth another look, right. Okay, so we're going to try to do this on a moonlit night. Yeah, I think it's going to show up. Just tuning up this large histogram. It's amazing, even on a moonlit night with just 80 seconds, we can already tell that something is there. I think if you were outside with a lens, you know, with an eyepiece, this would just all be one big flooded, light polluted, moonlight polluted sky. Look how bright all that is. Look how bright the telescope is. Yet, with the help of electronically assisted astronomy, we're already seeing this outward arm here after 120 seconds, which seems so impossible. Let's go back to Stellarium. See, look, we're seeing that outward arm that has that dark, whatever that is. If that's either a like dark nebula in front of it. Now you see why they call it Needle's Eye Galaxy. We're seeing the needle's eye already, right here. seems so improbable that we would not only be able to see the galaxy period, but that after 3 minutes we're already distinguishing this eye of a needle. On an 80% moonlit night. The void contains some older, redder stars, but no younger, bluer stars. So what would that tell us, Stu? That maybe it's black material that's covering up that part of the galaxy? And the older, redder stars are just in the way between us. After just 3 minutes, we could already start making out the eye of the needle without having been prompted by stellarium. EAA rocks. This is a beautiful galaxy already. Looks ghostly, floating in the 80% moonlight and light pollution. What part of the night sky is this? Let's back off and look at our context. This is due south, and it's 31 degrees above the horizon. For our view tonight, NGC 247 was due south, 31 degrees altitude. It's 70,000 light years in diameter, according to Stu. Smiley face. Around 11.1 million light years away. Claw galaxy. We liked the Needle's Eye, Galaxy 2. You can see that brighter core. But I tell you what, this would look a lot better on a dark night without all that moonshine. So the moon does present its share of problems, doesn't it? Wonder why it didn't allow me to do that either. I'm going to write these down, I guess. Old-fashioned list. Or put them in. Yeah, I guess I'll just write them down. That's as easy as anything. Because I'm going to have to report these to Phyllis, and not letting us log them, in other words. Lots of bluish stars in there, huh, Stu? And you're saying in this void, They're just these couple of red ones, but no young blue ones. So I think it's dark matter there. Okay, one more object. Let's go to 74 PSCA, a double star. Why are we looking at a double star? Because this is Cosmic Challenge, not all deep space stuff. I don't think there's any sense in saving that. It's not a very picturesque view, is it? The next object is 74 PSCA, for whatever that's worth. Mono camera with the hydrogen alpha filter works great, even with the moonlight. If you're viewing hydrogen alpha, right? But if you're not viewing hydrogen alpha, does it still work? Like I could see where it would work with a hydrogen alpha region like a nebula. Oh, look at this cool double star. That's awesome, isn't it? Oh wait, you're looking at the, look at that double star right in the middle. Isn't that cool? Right now it's very tiny, but we'll let it do the plate solving first. This is object 38. Autumn binary tests. Did we do this before? Maybe I just haven't solved the problem. Maybe we couldn't mark them off because it wouldn't let us mark them off, I bet. .74 PS. I'll have to give it a test and see. Okay, it still works on other objects. All right, Ray, we'll look forward to that. 74 PSCA. I bet we did this and it wouldn't let us mark them as observed. If so, I'll send this in to Phyllis tomorrow and say, Phyllis, help us. We want to mark these off. I don't know why we would live stack a double star, because it's just going to cause it to bleed together, isn't it? We were better off before we went to the longer exposure, weren't we? Yeah. So we're going to turn this back off and go back to the 3-second exposure at 400 gain. And here we see the double star perfectly. Okay, most of the objects have some H alpha in around them. I bet you're right. I mean, I know you're right. You are right. We could split this with no problem. Yeah, it won't let us mark that off the list either, sadly. So we're going to have to ask her what's up with that. Let's go to the next one, Zeta PSC. Not very far away, huh? Wow, look at that. You can see these perfectly too. Okay, let's go to Lambda Ari. Hipparchus 9153. A lot of people spend a lot of time going to look at double stars. I've just never gotten into it very much. And I think what they do is kind of what we're doing here. It's like a test for the telescope to see if you can split them. And I suppose it is, you know, fun to test your scope like that. Just never gotten into it very much. But now we are. Wonder which one we are. Let's do a, I bet it's right here. Let's do a plate solve and see. Could be this. 38 Lambda Ari. I bet one of these is fairly bright, so we might not be pointed at it yet. Lambda Ari is a single star, I see. But it must have a companion, right, Stu? There it is, look. Oops, sorry. There it is in the middle. There's Lambda Ari. And that must be its companion. A close set pair, 4.8 magnitude primary teamed with a 7.3 magnitude companion. Well, I'm so happy because I remember the night that we were doing these, we were live stacking them, which was crazy. Let's go to the fourth pair, 30 Ari. And I remember, I don't remember if you guys were on that night or not, but I remember feeling really bad because I said, well, this is such a shame that our RASA can't split these. But the reason we couldn't split them is because using live stacking, we were bleeding them. And we were, what did you call it, Stu? There was a name for it, like overfilling the pixel buckets. How do you just say that again? Over something, over modulating, over something. So this is our final pair, and we got this one too. This is 30 Ari. Some people say they look yellowish through telescopes. Boy, that's not even challenging for us, is it? It's so easy to split those. Oversaturating, that's it. Okay, we're not going to be able to mark these off, sadly. I don't think. Let's try 30 Ari one more time. But I will contact her tomorrow and ask her for help Nope. I'll ask her for help on these. 74 PSC, lambda, RE, 30 RE, and Zeta PSC, which must mean Pisces. Scope cam view, so sorry. So, you know, these are easy to split too. Now, maybe the ones we were splitting were from a different season, because these are called autumn binary tests. But I feel much better about these than I did that night we were doing the binary test before. Okay, well, this wraps up our 2 hours. Thank you guys for hanging with us. This Cosmic Challenge series is a lot different from the other lists that we've done, which are focused on deep sky objects, whereas the Cosmic Challenge is taking us to places like Vesta and splitting binaries, you know. But I think it's good to broaden us as amateur astronomers, and it's good for us to test ourselves so we kind of get to know our equipment better and what we can manage. This will let us know precisely what the telescope's capable of doing. So I like all of this, and thank you guys for being a part of it. Thank you all that's been on the stream. Ray, that's kind of you to say another great night. If you guys do like this kind of content, remember, please hit the thumbs up, like it, whatever it is. And then if you like to be notified of this, go ahead and subscribe on YouTube. Don't forget, you can also go to emeraldhillskies.com and subscribe to the email list. And that'll email you usually 24 hours in advance. We usually send you a community notice on YouTube, and then we create the live stream event. So hopefully YouTube notifies you as well. Thanks to God for making all this cool stuff that we could go see. And thank you for being a part of Emerald Hill Skies. I love this team astronomy thing. We'll look forward to seeing you again, I hope, in another week or so, the first clear night that we have. And again, thanks. God bless. Good night, Vic. Vic says, sweet dreams to all. Good stuff, Vic. Thank you guys that have stuck with us, and we'll look forward to seeing you next time. God bless.